This lesson, we're going to learn how to solve radical equations. A radical equation is an equation with a square root or cube root, etc. In order to solve, we need to remove the square root by squaring the both sides of the equation or removing the cube roots by cubing both sides of the equations. Then we will find our solutions. However, those solutions may not actually work. Therefore, we always need to substitute them back into the original equation to see whether or not it satisfies the equation. Let's do some examples to see how we solve radical equations. Example 1. 2 square root of y equals 13. So first, we square both sides. Then, we're going to find out what will be 2 square root of y whole thing square, which means 2 times by 2, which is 4, square root of y times by square root of y, which is y. Then, we're going to have 4y equals 169. Divided by 4 on both sides, you get y equals 169 divided by 4. Before we make the conclusion, we want to make sure this satisfies the original equation. So left-hand side is 2 square root of y. Substitute the value of the y that we find. We got 13. And we know right-hand side is also 13. Because left-hand side equals right-hand side, therefore we say y is 169 over 4. Example 2, as you can see, we have radicals on both sides of the equation. So first, we're going to isolate all the radicals to the left and all the constants to the right. Then we collect the like terms. We get 3 square root of x equals to 6 divided by 3 on both sides. Now we have to remove the square root by squaring both sides of the equation. Now we get x equals to 4. Once again, we have to verify our solution. Therefore, we do left-hand side equals the square root of x plus 1. Substitute the value into the x. Now we get 3. The right-hand side equals 7 minus 2 square root of x. Substitute 4 into the x. Now we get 3. Since left-hand side equals the right-hand side, therefore, x is 4. Example 3. The radical is already isolated on the left, so we just need to square both sides to remove the square root. And on the right-hand side here, it is a perfect square, so we're going to use perfect square formula to expand it. Next, we are solving for a polynomial equation. That means on one side of the equation, it needs to be a 0. So we're going to subtract 3p and subtract 13 on both sides of the equation. Now we get a quadratic trinomial. Then we're going to factor them into 4p plus 1 times by p minus 4. So we can solve for p now. 4p plus 1 equals 0 means p equals to negative 1 over 4. Or p minus 4 equal to 0 means p could be 4. Now we have to verify our solutions. So let's check the first one. P equals negative 1 over 4. The left-hand side equals the square root of 3p plus 13, which is square root of 49 over 4. That means square root of 49 over square root of 4, which is 7 over 2. On the right-hand side, we get 2p minus 3, which is negative half minus 3, which is negative 7 over 2. As you can see, left-hand side and right-hand side, they are not the same. Therefore, this p-value is invalid. Next, we're going to check p equals to 4. So on the left-hand side, square root of 3p plus 13, we get square root of 25, which is 5. On the right-hand side, we get 2p minus 3, which is 8 minus 3, which is 5. So we can see left-hand side equals the right-hand side. Therefore, it is a correct answer. Therefore, p equals to 4. Example 4, we have square roots on both sides of the equation. So one way to do it is to isolate the radicals first, and then you square both sides of the equation to remove the square root. Or we can square both sides of the equation first, and then we isolate the square root on one side of the equation. It does not matter which way you choose to do. However, the amount of radicals on one side of the equation should not be more than 2. Otherwise, the solving will become very complicated. Now, let's square both sides of the equation before we isolate the radical. We use binomial expansion or perfect square formula, we will get to the second line. However, now we have to isolate the radical, so I have to remove the m and remove the phi on both sides of the equation. Now I get n plus 4 equals 4 square root of n plus 1. Since we have a square root again, that means we have to square on both sides of the equation to remove the square root. After that, we expand the right-hand side, and we have to have a 0 on one side of the equation because we are solving for a polynomial equation, so we have to remove 16n plus 16 on both sides of the equation. Now we get m squared minus 8m equals 0. In order to solve for n, we have to put this equation into the factor form. So we factor out the n, so we have m times by n minus 8 equals 0. This means n could be 0 or n could be 8. After we find the solutions, we have to verify it to see whether or not it actually satisfies the original equation. So let's check for m equals 0. We're going to do the left-hand side, which you will see the value will be 3, and we're going to check the right-hand side. The value on the right-hand side is also 3. Therefore, m equals 0 is a correct solution. Now, let's check m equals 8. On the left-hand side, we're going to get square root of 25, which is a 5. On the right-hand side, we're going to get 2 plus square root of 9, which is also 5. Therefore, we say m equals 8 is also another correct solution. Therefore, we have two solutions for this question. M could be 0 or 8. Example 5. There are 3 radicals in total in an equation. So we will put 2 on one side of the equation and we'll put 1 on the other side of the equation. Then we square both sides to remove the square root. Let's pretend this is our a term and this is our b term. So we have a minus b, whole thing squared. That's a perfect square. So our expansion will be a squared, which means you remove the square root, minus 2 times by a times by b, plus b squared, which means we just remove the square root, equals to whole thing square on the right-hand side, we just remove the square root, becomes x plus 2. Next, let's isolate the radicals on the left, and let's take a look on the right-hand side. We do x minus 2x, we get negative 2x. And 2 plus 1 minus 5, we get negative 2. Before we square both sides of the equation to remove the square root again, we see they all have a negative 2 in common. That means we're going to divide every term by negative 2 to make the equation more simplified. Then we square on both sides of the equation to remove the square root. On the left-hand side, we're going to get 2x plus 5 times by x minus 1. On the right-hand side, that's a perfect square. So we can use the perfect square formula. We will get x squared plus 2x plus 1. Now, let's expand the left and collect the like terms and push everything to the left because we are solving for an equation. So we need to have a 0 on the right-hand side of the equal sign. Then we're going to have x squared plus x minus 6 equals 0. We factor them, we get x plus 3 times by x minus 2 equals 0, means x plus 3 equals 0, that means x equals negative 3. Or x minus 2 equals 0, means x equals 2. Now we have to verify our solutions. So for x equals negative 3, we substitute back into the original equation to check the left-hand side. You see the value inside the square root is negative, which is invalid. Therefore, x equals negative 3 is not a proper answer. The other one, x equals 2. The left-hand side will be square root of 9 minus square root of 1, which is 3 minus 1, which is 2. The right-hand side will be square root of x plus 2, which is square root of 2 plus 2, which is square root of 4, which is 2. So you can see left-hand side equals the right-hand side. Therefore, x equals 2 is the right answer. Therefore, the answer for this question will be 2.